is 97U, line 22, 97, 7B97, beam Tetrode plates, UFO, 5G Wow Seti. There's the alien radio signal there. There's that there. Okay, so this is a beam Tetrode signals for communication UFO space, line 22, Wow Data Keyword Research. July 26, 2013, today's August 18th. The phase space to Triode to Pentodes is a keyword in previous videos, formula of ideas. So line 22, 7B97 is ECC83 Triode Amplifier Voltage UFO 5G Wow Seti, and it's 97T. So these were the words I was supposed to Google from that video. It was beam Tetrode, Pentode, transistor, valve audio, amplifier, technical, in another video. Quotes and diagrams are from wiki. The keyword is going to be beam Tetrode in this one. A beam Tetrode, sometimes called a beam power tube, is a type of Tetrode valve or tube with auxiliary beam focusing plates designed to augment power handling capability and help reduce unwanted emission effects. These tubes are usually used for power amplification, especially at audio frequency. There's a picture of one here. Inside of a beam Tetrode tube with an anode cut open, the beam plates are the silver colored structures to the left and right. This is a beam triode with a hollow anode cylinder, and this is a twin beam Tetrode RCA 815. History. The problem of secondary emission in the Tetrode tube valve was solved by Phillips Mullard with the introduction of a suppressor grid to produce the Pentode construction. Since Phillips held a patent on this design, other manufacturers were keen to produce Pentode type tubes without infringing the patent. In the UK, two EMI engineers, Cabot Bull and Sidney Rada, produced and patented an alternate design in 1932. The design had the following features compared to the normal Pentode. The control on the screw grids were wound so that pitches were the same and the wires were in alignment. The Pentode used different pitches. A pair of beam forming plates was added at the two ends of the oval grid structure to focus the electron stream into a pair of beams 180 degrees apart. The Pentode added a third grid. These plates are normally connected to the cathode. The design is today known as the beam Tetrode, but historically was also known as a kinkless Tetrode, since it's electrode device without the negative resistance kink in the anode current versus anode voltage characteristic curves of a true Tetrode. Some authorities, notably outside the United Kingdom, argue that the beam plates constitute a fifth electrode. The MI design had the following advantages over the Pentode. The screen grid current was about 5 to 10% of the anode current, compared with about 20% for the Pentode. Thus the beam Tetrode was more power efficient. The design introduced significantly less third harmonic distortion into the signal than did the Pentode. The design produced more output power than a similar Pentode. Disadvantages of the beam Tetrode were: it had higher inherent intermodulation distortion than the Pentode. It could be ameliorated by adopting an ultralinear design and a push-pull circuit. This connection links the screen grids to taps on the output transformer. Negative feedback also reduced harmonic and intermodulation distortion. The beam Tetrode required a larger input signal at the control grid for a given power, requiring to be driven by a higher gain stage than a Pentode. The beam Tetrode had more tendency to oscillate than a Pentode if the circuit was not designed and laid out properly. So the keyword beam Tetrode is going to continue in the next video. Thanks for watching.